from the Midwest. So I figured what would be a great video to do for you guys today was convenient with the snow outside because it's actually coming down right now. And it is holiday season, as you guys can see from my sweater. So there is ice on Mercury, which is crazy for it being the closest planet to the sun. How is this even possible? Let's pretend this is Mercury. The northern and the southern poles actually face away from the sun year-round and are always in the dark. These areas are called cold traps, and they are extremely cold. And this is actually where we found ice. Temperatures here are less than 100 degrees Kelvin, or negative 173 degrees Celsius, or negative 280 degrees Fahrenheit. That's really cold. 25 years ago, the Arecibo Observatory in Puerto Rico received radar signals showing strong reflections from Mercury's poles. These reflections indicate pure ice layers, just like on Europa, which is one of the moons of Jupiter. Now, we also did measurements of our own moon because it is very cold, so we presume that there will be ice on the moon, right? It ended up coming up dry, more than 3 times the amount of space on the moon as opposed to Mercury for the option for there to be ice. This calls for some analyzing. Well, first off, Mercury is about 3 times bigger than the moon. However, Mercury is about 1/3 closer to the sun than the moon is. The moon is about 3 times further away from the sun than Mercury is. Some forensic planetologists, which are just scientists that study the history and the structure of planets, did some observing. There's about 26,000 square kilometers of cold traps on the moon, and there's only about 7,000 kilometers of cold traps on Mercury. Another funny thing is the area that's underneath the surface of these two celestial bodies.
Acknowledged.
Ice can survive for up to temperatures of 125 degrees Kelvin. It's also negative 148 degrees Celsius or negative 235 degrees Fahrenheit. Now, how much space is available on the entire surface of the moon for this type of ice to survive? 240,000 square kilometers. And how much is on Mercury? Only 50,000 square kilometers. So now that's 2 different forms of evidence that would show us that there should be more ice on the moon than Mercury, right? Well, actually the answer is no. To explain, it's time to get something called a neutron spectrometer involved. Neutron spectrometer is the device that detects neutrons when they're being knocked off the soil of planets or moons due to cosmic rays. Now, a cosmic ray just comes from the sun. It interferes with the surface of planets, and because the cosmic rays contain something called hydrogen, neutrons are being knocked off the surface, they come across hydrogen atoms. And why are hydrogen atoms so important? Because what is water made of? H2O, 2 hydrogen atoms and 1 oxygen atom. And what creates life? Water. So these neutrons are being knocked off the surface. And what is water when it's frozen? Ice. And so why is this so important? Because we want to know if there's more ice on Mercury than on the moon. This neutron spectrometer just got to be a lot cooler, pun intended. Just to clarify, we do not visibly see neutrons being knocked off the surface when the cosmic rays come into contact with it. A neutron spectrometer measures wavelengths. So wavelength can either be strong and short or can be very long but weak. We can figure out that a neutron was knocked off the surface. It gives off a weaker wavelength after it comes in contact with a hydrogen atom.
Now here's a little cartoon I drew to help demonstrate it for you guys. Let's say this is the neutron spectrometer. It can pick up different wavelengths. So let's say this is the neutron that's on the surface of Mercury inside of its soil or dust that's on the surface. And it has really high energies, so it's setting off really short and strong wavelengths. Now what happens is when it comes in contact with a cosmic ray, it hurts it a little bit. It does interfere with it, and it harms it. The next step is it comes in contact with hydrogen. Either the hydrogen comes from the cosmic rays, or the hydrogen is within maybe possible ice that's here on the surface of Mercury. And what's happening is that it then comes in contact with the hydrogen, it harms it one more time, it becomes weaker. And when it becomes a lot weaker, it gives off really long wavelengths, because neutrons, when they get interfered with hydrogen or with cosmic rays, it then becomes very weak, and it then gives off really weak wavelength signals. And the neutron spectrometer picks that up and is like, hey, something's going on with the surface of Mercury. And the next thing that would actually happen is this neutron would then get knocked off the surface of Mercury because of these cosmic rays, which were so strong and harsh on it. So it would get totally knocked off the surface of Mercury. And we would pick that up on our neutron spectrometer.
After knowing this, what did the scientists find? We found no more than 0.5% of hydrogen on the moon. Remember what we said? H2O, aka water, aka frozen H2O, is water ice. And so 0.5% is like nothing. That means there's like no ice on the moon. Okay, so what about Mercury? 100% hydrogen we found on Mercury. Does this prove to us that there's actually more ice on Mercury than on the moon? What about all the unavailable space for all the cold traps that we found on the moon? According to Mr. Neutron Spectrometer, there's 400 times more ice on Mercury than on the moon. Thanks, Messenger spacecraft, for all that data with your neutron spectrometer. Now, data from the LaCrosse mission for the moon shows us that there's only about 4 to 5% of ice under its surface. Let's scale this in a fun way. And for this, I will need to go outside and get some snow. If we were to take all the ice that we found on Mercury and smush it into one snowball, its diameter would be about 4,600 meters in length. That's a lot of snow. The height of this mountain is 4,600 meters tall, which would be the size of the diameter of this snowball. That's a lot of snow.
That makes a lot of Frosty the Snowman. Frosty the Snowman.
Now I'm going to conclude on this question. If we have data showing us that there should be a lot more ice on the moon than over Mercury, then why do we have data and evidence proving us otherwise? Well, for one thing, micrometeorites. There are about 10 times as many objects that hit Mercury than hit the moon. And about 50 times more often, micrometeorites hit Mercury than they hit the moon. And this is because of its location to the sun. It's much closer to the sun than the moon is. One big issue is that the sun has such a strong gravitational pull that a lot of objects that are floating around our solar system get very attracted towards the sun, and they start to get in orbit around the sun. And what happens? Mercury, being the closest planet to the sun, oftentimes ends up being in the path of these objects as they're getting pulled into the sun, and a lot of times will end up hitting Mercury. Now, why do we even care about micrometeorites? Because micrometeors are bits and pieces of other planets or other moons, and other planets and other moons contain lots of elements, which include hydrogen. Again, as we're talking about hydrogen being such an important element in our solar system and in life. Hydrogen creates water, and water creates life. It creates ice, and we're looking for ice right now. Another hypothesis are stellar winds. Now, hydrogen also is found in our sun, and so stellar winds are exactly what it sounds like. The sun is a star, and when it's rotating extremely fast and quickly, it's creating stellar winds. So it's actually blowing winds because it's constantly turning. With the sun being this extremely massive gaseous object, a lot of times while it's spinning, because it's gaseous, a lot of its materials can end up being blown out inside the stellar wind. And a lot of its materials are hydrogen. And so if its stellar winds are smashing into Mercury, a lot of its elements like hydrogen are smashing into Mercury and can end up bringing H2O to the planet. It shows us that even when there were multiple reasons proving us why we should believe one thing, we continue to question, we continue to observe, analyze, and we ended up concluding on a completely different result. This is why I love science. It's gotten me to think this way about a lot of things in life, actually. If you have an idea and there's 1.5 million reasons why it shouldn't work, but there's one possibility that it might, just grow from that. Because who knows, you might end up finding ice on a planet that's 90% deep fried. Thanks for watching, guys. I'll see you guys next week. Quote from my dad: live long and perspirate. Till next time. Bye, guys.